warahmatullahi wabarakatuh. My name is Suci Sari. You can call me Suci. I'm from Indah 2018. Study program is Physics Education, Faculty of Mathematics and Natural Science in Malang State University. I will make a video that will explain about microscope. This video is for fulfill assignment of English for Physics, and this video dedicated to Mr. Nurul Hidayat as an English for Physics lecturer. So, watch this video. A microscope is an instrument used to see objects that are too small to be seen by naked eye. Microscopy is the science of investigating small objects and structure using such an instrument. Microscopics mean invisible to the eye unless aided by a microscope. 1. Optical microscope. You are probably most familiar with optical microscope, also called light microscope. This type of microscope magnifies specimens through the use of lenses and visible light. The oldest and simplest in design, this is the microscope most likely to be used by students, hobbyists, and certain types of scientists. We divide optical microscope into three main categories. Number 1 is compound of microscope. Most people immediately recognize a compound microscope from seeing them in movies or using them in their student days. The original microscope design was a compound optical, and it's still the most commonly used today. A compound microscope works by illuminating the slide from underneath with a light bulb. The specimen is then magnified by a series of lenses, one near the slide called objective lens and one near the top called the eyepiece. This results in a two-dimensional image that you can adjust depending on the strength of your lenses. Number 2 is stereo microscope. A stereo microscope differs from a compound microscope in a few key features. The most critical difference you may notice is that it had two eyepieces instead of one. The purpose of the stereo microscope is to produce a three-dimensional image, hence the two eyepieces that send a different image to the right and left eye. The specimen is usually lit from above rather than underneath. This makes the stereo microscope ideal for dissection, inspection, circuit board work, manufacturing, or use with any opaque specimen. Number 3 is confocal microscope. Unlike stereo and compound microscope, the visible light source comes from a laser. The laser scans the sample with the help of a series of scanning mirrors. Assemble the image in a computer and display the image on a screen. No eyepiece here. 2. Electron microscope. Many people have heard of this but are not clear how they actually work. Put simply, an electron microscope scans with electrons rather than visible light, resulting in a very detailed and awesome-looking image. This works because the wavelength of the electron is much smaller than the wavelength of light from a bulb or laser, allowing for greater detail when scanning. There are too many types of electron microscope. Number 1 is scanning electron microscope. Scanning electron microscope sends a beam of focused electron to the sample, which bounces off the creates a three-dimensional surface image. With this method, you can create a picture with high magnification and high resolution, but it will always be an exterior view. Number 2 is transmission electron microscope. Transmission electron microscope work by sending the beam of electrons through a very thin specimen, so rather than scanning over and bouncing off, the electron pass through the sample to create a highly detailed two-dimensional image. Electron microscopes are very expensive and technical to use, thus they are for serious scientists, not students or hobbyists. There are some disadvantages of electron microscope, but their contribution to research is invaluable. Most other types of microscope are less common and used by research scientists. These include 1. Scanning probe microscope. They scan the sample with a physical probe. The tip of probe raster scan goes line by line the specimen and generates an image with a computer. 2. Scanning acoustic microscope. This use a principle similar to sonar in that they employ sound wave to measure the sample. 3. X-ray microscope. This one use electromagnetic radiation in the form of X-ray to produce images of tiny objects. 1. Eyepiece lens. The lens at the top that you look through, they are usually 10 times or 15 times power. 2. Tube. Connect the eyepiece to the objective lenses. 3. Arms to support the tube and connects it to the base. 4. Revolving noise piece. This is the part that holds 2 or more objective lenses and can be rotated to easily change power. 5. Objective lenses. Usually you will find 3 or 4 objective lenses on a microscope. They almost always consist of 4 times, 10 times, 40 times, and 100 times powers. 6. Stage. The flat platform where you place your slide. Stakes, clips hold the slide in place. If your microscope has a mechanical stake, you will be able to move the slide around by turning two knobs. 7. Diaphragm. Many microscopes has a rotating disc under the stake. This diaphragm has different size hole and is used to vary the intensity and size of the cone of light that is projected upward into the slide. There is no set rule required with setting to use for a particular power. Rather, the setting is a function of the transparency of the specimen to the degree of contrast you desire and the particular objective lens in use. 8. Illuminator. A steady light source used in place of a mirror. If your microscope has a mirror, it is used to reflect light from an external light source up through the bottom of the stake. 9. Base. The bottom of the microscope used for support. 1. When moving your microscope, always carry it with good hand. Grab the arm with one hand and place the other hand under the base for support. 2. Turn the revolving noise piece so that the lowest power objective lens is clicked into position. This is also the shortest objective lens. 3. Your microscope slide should be prepared by placing a cover slip or cover glass over the specimen. This will help protect the objective lenses if they touch the slide. Place the microscope slide on the stick and fasten it with the stick clips. You can push down on the back end of the stick clip to open it. 4. Look at the objective lens and the stick from the side and turn the coarse focus knob so that the objective lens move downward or the stick, if it goes upward, move it as far as it will go without touching the slide. 5. Look through the eyepiece and adjust the illuminator or mirror and diaphragm for the greatest amount of light. 6. Slowly turn the coarse adjustment so that the objective lens goes up away from sight. Continue until the image comes into focus. Use the fine adjustment if available for fine focusing. If you have a microscope with a moving stick, then turn the coarse knob so the stick move downward or away from the objective lens. 7. Move the microscope slide around so that the image is in the center of the field of view and reaches the mirror, illuminator or diaphragm for the clearest image. 8. Now you should be able to change to the next objective lens with only minimal use of the focusing adjustment. Use the fine adjustment if available. Don't allow the objective lens to touch the slide. 9. The proper way to use a monocular microscope is to look through the eyepiece with one eye and keep the other eye open. This helps avoid eye strain. If you have to close one eye when looking into the microscope, it's okay. Remember, everything is upside down and backwards. When you move the slide to the right, the image goes to the left. 10. Don't touch the glass part of the lenses with your fingers. Use only special lens paper to clean lenses. 11. When finished, raise the top or lower the stick. Click the low power lens into position and remove the slide. 12. Always keep your microscope cover when not in use. Dust is the number one enemy. So, this is the end of my video. Sorry if there was a mistake in this video. I hope this video can be useful for you. Thank you for watching and goodbye. Wassalamualaikum warahmatullahi wabarakatuh.
Why 그렇게 널 보내고 온